Welcome to this tutorial on implementing lighting and shading in Java. Today we'll explore how to create realistic lighting effects in our 3D applications. Let's dive right in. To start with, let's ensure we have our environment set up. We'll be using Java with a graphics library. In this tutorial, we'll employ JavaFX for rendering our 3D objects. Make sure you have the latest version of Java and JavaFX installed. Now, let's create a basic JavaFX application. Open your IDE and create a new JavaFX project. In the main class, we will set up a scene and a camera. Here's the code you'll need. Let's break down this code. We import necessary JavaFX packages, set up a primary stage, and create a scene with a light blue color. We also added a perspective camera which allows us to create 3D effects. Now, let's add a simple shape to our scene. Here, we created a sphere and applied a Phong material, which provides a shiny appearance. The diffuse color represents the main color of the material, while the specular color defines the color of light reflecting off the material. Next, let's introduce a light source to enhance the appearance of our sphere. We'll add a point light to our scene. In this part, we created a point light, which emits light in all directions. We can adjust its position to create different lighting effects. Now let's see how this looks in our application. Compile and run the application. You should see a blue sphere illuminated by a yellow light. This is the basic setup for applying lighting in JavaFX. Now that we have a basic understanding of lighting, let's explore different types of lights available in JavaFX. Besides point light, we also have ambient light and directional light. Each serves a specific purpose. Let's start with ambient light. Ambient light simulates indirect light that affects all objects equally, regardless of their position. This helps in reducing stark contrast between light and shadow. Next, let's implement directional light. Directional light mimics sunlight by emitting light in a specific direction, which can create dramatic shadows in our 3D scene. Now we have a directional light that casts shadows based on the direction we've set. You can experiment with this direction for different shadow effects. To see the effects of these lighting elements better, let's add some more shapes to our scene. We can add a cylinder and a box to observe how they react to different lights. This code adds a vertical cylinder and a cube to our scene. After implementing this, run the application again. Observe how different materials and lighting interact with each shape. Now that we've added more shapes, let's talk about shading techniques. We can create different visual styles by modifying material properties like shininess and reflectivity. This line adjusts how shiny the material looks. A higher value means a shinier appearance. Play with this value to see how it affects your shapes. Let's also look at using textures in our materials. Textures can provide a more realistic appearance to our 3D objects. To add a texture, we need an image file that we can apply to our material. By applying a texture map, you can enhance the visual fidelity of your shapes. Make sure you replace path /to/your/texture.png with the actual path to your image. As we continue our exploration, it's essential to understand the balance between different types of light and how they affect the overall ambience. You may want to experiment by adding multiple lights in different configurations while adjusting their colors and intensities. This will help you learn how to achieve desired effects. Now, let's review how lights can cast shadows in JavaFX. The shadows add depth and realism to your 3D scene. Shadows are automatically calculated based on the lights and the shapes present. Here, we're ensuring that depth testing is enabled for the scene, which helps in rendering shadows realistically. Now, rerun the application to observe the shadows in action. If you're not seeing shadows as expected, make sure that all the lights are set up properly and that you're using appropriate materials. Adjust the lights and object positions if necessary. Finally, let's talk about performance considerations. Lighting calculations can be intensive, especially with multiple lights and shadows in the scene. Optimization is key to achieving smooth performance. You can optimize by simplifying materials, reducing the number of lights, or employing level of detail techniques where complex objects decrease in detail when further away. To sum up, today we explored how to implement lighting and shading in JavaFX. We discussed different types of lights, materials, shadows, and performance considerations. Experiment with these concepts in your projects to create stunning visuals. Thank you for watching. Don't forget to like, share, and subscribe for more Java tutorials. See you next time.